Today we're going to be talking about probability for simple events. A simple event can only happen one way or has a single outcome. Probability notation, when trying to find the probability of an event that will occur, we write it as P and then parentheses, whatever that event is. So for the probability for rolling a 2, we'd say P parentheses 2, and then we write the probability. And again, probabilities can be written as a fraction, they can be written as a decimal, or they can be written as a percent. It does not matter. Okay, so the probability that an event will happen is the number of ways that the event can occur versus its possible outcomes. So the first thing we have to do is find the number of possible outcomes, then find the number of ways that that specific event can occur. Then we divide and simplify. So here we go. We have this lovely spinner. It's numbered 1 through 6. All the slices are the same size, so they would all be equally likely to occur. So what's the probability? We roll a 5. Well, there's 6 slices. One of them is a 5. So that's a 1 in 6 chance. That is a 0.17 when we round. So that would be a 17%. What's our probability that it's an even number? 2, 4, and 6. That's half of the numbers. So that's 0.5 or 50%. Probability of rolling a 1. That's a 1 in 6 chance again. Probability of getting a 0. There's no 0 on that spinner. That's not going to happen. Probability of getting a 3 or a 5. Well, that's 2 out of the 6. So that simplifies to 1/3. We do want to always put our answers in simplest form. So that's 0.33 or 33%. Probability of getting something less than 5. So that's going to be 4, 3, 2, and 1. So that's 4 out of our 6. Or 2/3, which is 0.67 when we round. So 67%. Greater than 5. So that's just 6. So it's a 1 in 6 chance. So 0.17 or 17%. And probability that it's less than 10. Well, that's all of them. Okay. In a bag of marbles, there are 4 green marbles, 2 purple marbles, 6 red marbles, and 7 yellow marbles. What is the probability that you will randomly select a red marble? So how many marbles are in the bag? 4, 6, 6, so that's 12 plus 7, so there's 19 total marbles. And red, there are 6. So you have a 6 in 19 chance, which is 0.32 or about a 32% chance. A box is filled with 12 red crayons, 5 blue crayons, 7 yellow crayons. A crayon is chosen at random from the box. Find the probability that it is a blue or a yellow crayon. So how many crayons do we have? Looks like we have 24 crayons in the box. And blue, we have 5. Yellow, we have 7. So we have 12 of either one of those total. So that is, you have a 50% chance of either pulling out a blue or a yellow crayon. All right, we have something called theoretical probability and experimental probability. Theoretical probability is found without looking at data. It is what should happen. So we just did theoretical probability, okay? We didn't actually experiment to see what happened. We just said, okay, if you toss a coin, what is the probability that you're going to get heads? What is the probability that you're going to get tails? Experimental probability is found using the data from an actual experiment and calculating the probability. Okay. So the spinner below has 10 equally sized slices. We have 4 gray, 4 white, and 2 black. Jenny spun the dial 25 times and got the following results. Okay, so she spun it and she got 12 gray, 9 white, and 4 black. Okay, so she did it 25 times. So it says fill in the table below or answer the questions below. Round your answers to the nearest thousandth. Assuming that the spinner is fair, so you have an equal chance of landing on each piece, compute the theoretical probability of landing on gray. Well, you have a 4 in 10 chance of landing on gray. So that's 0.400 when you round to the nearest thousandth. From Jenny's results, compute the experimental probability of landing on gray. So she got gray 12 out of the 25 times that she spun. That's 0.480. Assuming that the spinner is fair, choose the statement below that is true. With a large number of spins, there might be a difference between the experimental and theoretical probabilities, but the difference should be small. With a large number of spins, there must be a large difference between the experimental and theoretical probabilities, or with a large number of spins, there must be no difference between experimental and theoretical probabilities. Okay, so what do you think there? Well, there's probably going to be a little bit of human error in there. Maybe the spinner isn't exactly perfect, but if you do it enough times, you should get pretty close to theoretical if you do your trials enough times, but you probably won't be exact. Okay, so you'll get close, but maybe not exact. The State Lottery Board is examining the machine that randomly picks lottery numbers. On each trial, the lottery machine outputs a ball with one of the digits 0 through 9 on it. The ball is then replaced in the machine. That means they put it back. The lottery board tests the machine for 50 trials and got the following results. Fill in the table below, or that means answer the questions. Round your answers to the nearest thousandth. Assuming that the machine is fair, compute the theoretical probability for getting a 1 or a 4. Okay, so there's 10 digits. So that would be 2 out of the 10. So that would be 0.200, round to the nearest thousandth. Okay. From these results, compute the experimental probability of getting a 1 or a 4. So I'm going to look at the 1. I'm going to look at the 4. So the number of trials, we had 4. So that means out of the 8 trials. No. Sorry. The results, we got 8 out of the 50 trials, which is 0.160. Okay, assuming that the machine is fair, choose the statement that works. As the number of trials increases, we expect that the experimental and theoretical probabilities will become closer, though they may not be equal. That would be the statement that would work. Sorry. And our last example of the day. The spinner below shows 10 equally sized slices. Heather spun 200 times, and this is her result. From Heather's result, compute the experimental probability of landing on black. So she got black 30 out of her 200 times, which is 0.150. Assuming that the spinner is fair, compute the theoretical probability. So a black would be 2 out of 10, which would be 0.200. And assuming that it is fair, the larger the number of spins, the greater the likelihood that the experimental probability will be close to the theoretical probability. So first statement again. All right, good luck.